All right, let's get this show started. So, welcome to the Go Into Game with Lua and Love2d workshop. As far as I can tell, the main difference between a workshop and a full talk is that in a workshop I'm going to be coding and you guys get to watch me code and then ask questions during and after. And I get to do my best to live code and not have everything just blow up in my face. To begin with, obviously you can see I prepared these slides that are totally not the same as my other talk slides. But let me introduce myself really quickly. I am Brooks Patton. I'm one of the lead instructors at Galvanize Full Stack Immersive. I've worked in the IT industry for over 10 years, and 8 of those years was with NASA as a systems administrator at the NASA Advanced Supercomputing Facility. One of the other things I do is I stream myself online on Twitch TV as I program a few times a week. And that's where this sort of talk came out of, because I do this type of thing several times where I go online and I program something. I usually try to finish it in one night. I usually give myself about an hour and a half or so though. Tonight we get about 45 minutes to an hour. So we'll see how far along we get. So, with that being said, that's the slides I have available for us. We're going to be using a technology called Lua2d. So, actually, Lua2d is the framework for, it's a video game framework that's sort of like, I think, similar to Unity, but also not really at all. So, Unity is the framework that tries to do everything for you. Like, literally everything it possibly can, which is really awesome. It makes you be able to make really big games, really like AAA level stuff. Lua2d tries to get out of your way as much as possible. Does mean that we have to do more coding to cover the gaps that they don't give us, like collision detection and other things like that. No physics engine in there either. But it uses Lua as the language. And Lua is a really awesome, fun language to program with. And show of hands, how many of you have played with Lua before? How many of you have heard of Lua? And just to make sure I get everybody's hands right up, how many of you have heard of programming? Okay. I just wanted to make sure everybody got a chance to raise their hand on that. Lua traditionally has been used a lot in plugins for other programs and other games. So World of Warcraft is a great example here. You can program a little small thing inside of a game. They don't use Lua to program World of Warcraft though. I think they use C++ or something. I haven't looked into it. So anyways, I wanted to sort of get into the programming pretty quickly, but if you wanted to get started and follow along later, and before I forget, I'm actually going to screencast this as well. So new screen recording, and go. Okay, so if you want to follow along with this later, you need Lua installed, and that's pretty easy. Just go find Lua on the internet, and then also you need Love. Love is pretty cool because you can install it on literally any kind of device as long as it's running an operating system and a computer. In fact, there's a PPA for Ubuntu, so I installed it on one of those systems this morning, and it was really just awesome. Okay, so with that being said, let's just show how easy it is to start with it, and then we're going to make Flappy Bird, or at least we're going to get as close as we can to a full Flappy Bird. So to begin with, let's just create main.lua. This is our beginning thing, and if I run Lua here, I get this wonderful blank window that has absolutely nothing else whatsoever, which probably not that surprising because we haven't actually written any code for it. So let's go and start that off. So I want to do the equivalent of a hello world. And if Adam is nice to me and actually loads. Okay, so in Lua, you write functions just like normal, but if you want to attach a function to an object, you don't have to go in with dot notation, or you sort of kind of do. You use function, and then love is what's given to us by love, and then love. Now, next thing is really cool, no curly brackets. So I'm going to create a couple functions here, love.load, love.draw. These functions are going to be run for us by love on their own. So to begin with, I want to create some global variables here. And by default, Lua actually makes every variable a global variable. And there is no like var keyword here, so I'm just going to say width equals love.graphics.get width, and height equals love.graphics.get height. Also, no semicolons. In fact, it will yell at you a lot if there's semicolons. So in draw, to finalize our little hello world here, I'm just going to say, first of all, we need to set the color. So love.graphics.set color. Let's make this white maybe. 255, 5, 5, and then love.graphics.rectangle. And here we need to say, I want to fill it with the color and not just have an outline. And I want to where to position it. I want to position it in kind of sort of the middle. I'm going to say, in fact, I realize now I probably want to do this in a circle because the middle of the circle is the center of the circle. A rectangle starts on the top left. To make this in the middle, I want to say width divided by 2, height divided by 2, and the size, 50. So that's it. I come back here, load it up, and we got a window with a circle in it. Okay, great. We're on our way, right? Obviously, things are going to get a little bit more complicated than this, but this is like the basics. This is how easy it is to get something on the screen with us. Okay, so I'm going to use a more object-oriented approach to this because Lua actually does allow you to program in an object-oriented style. Now, a lot of people compare Lua to JavaScript because of the lack of strict type checking and how it's a scripting language. And there's some things that are similar. There's some things that are very, very different. But it is very similar to a prototypical inherited language. So it's not really classical. Okay, so let's pretend that I have a verb. I'm going to say, local is the only keyword you have for a variable to make it local to this file or a function. So local verb equals required verb. We don't have a verb yet, but we'll get one soon. Then I want to say local verb. I'm not going to really set that up yet because inside of load, this is where they want us to put all of their actual true load stuff. So I'm going to say bird equals bird.new. There is no new keyword in Lua. So if you want to use something like a new keyword, you have to sort of add it into the class yourself. And then we need to give it a location. Well, I'm going to call it bird look. Should be look with capital L. Well, I need that here. So I need the look equals. Well, here's where it gets interesting. I need to pull in a vector library because Lua doesn't bring us vector libraries by themselves. So I do actually have one of those. I'm going to bring up Finder so I can go up one directory and find another vector, copy that, paste that in here. This vector library comes from a really well-named library called Lust. Far less laughs than I was expecting. The people who write Lua modules all really sort of got into the love aspect of it, and everything is written with kind of very lovey type names. Some of them dirty. And Lust is the least dirty of them. Okay, so local vector equals require. Vector. So the way a vector works is it's simply an object that has an x and y. But in this case, this vector library also gives me some methods that we'll be using a little bit later that makes it nice for me so I don't have to write those myself. So I just want to say bLocation equals vector.new, and I want to tell it with, actually, no, this is not circle. I want to say like in by 10, maybe down by 10. So x and y. I'm going to pass this into the bird, and then I need to tell the bird, hey, just display. That's it. Now you'll notice, and I guess this is, 10 minutes in I can ask, can you guys see the text all the way to the back? Right here between bird and display, that is not a dot, that is a colon. That's because Lua does allow you to access things inside of objects with the dot, but if you want to use this with object-oriented and have access to essentially the equivalent of this, then you need colon. It gets a little bit odd, it's a little bit of a learning curve, but once you get it, it's going to totally ruin your ability to switch back and forth between JavaScript and Lua. Okay, so obviously this will not work. We just coded a bunch, but we don't have an actual bird. So let's fix that really quickly. So new file, bird.lua, and in here, I'm going to put this over to the side so we can see both at the same time. So here's where it gets interesting. There are no arrays in Lua. There are only something called tables, but they have the object, like the curly brackets. So here's where it gets interesting. We're going to say local bird equals empty table. Then bird dot underscore underscore index equals bird. Totally makes sense, right? Yeah, this is one of those things where I just memorized it because it's a bit odd. Now we're going to do the same thing where on bird I want to attach a new function here. And this is going to take a location, and that's it. But inside, we have to do some magic in here to make it be a constructor function or a class. So, local, I just call these T for like table. I don't know, I just started doing that. I could easily call it bird inside of here, but then I realized I had too many birds. And okay, so set meta tables, another one of these black magic things. It's a function, you pass it in the internal table and the global table. And this turns it in to the class. Totally something that like you don't have to understand when you start programming this. You just have to find this online and start playing around with it. Now the next thing is to add things to like this keyword. We just say like t.log equals log. And unlike Node, where you have to like module exports, you just can return from a file, and that makes it available to the require function. Okay, so this is really cool. We got our location. We need our display function. So let's add that in here too. So function bird colon display. And I'm going to pass out anything. In here, we're just going to set the color again. So love.graphics.set color. Oh, right, delete that color. I was like, why isn't it auto-completing for me? What color should we make our bird? Red. Okay. It's RGB, so that means 255, 0, 0. And then we're just going to make we're going to make a rectangle. So love.graphics, rectangle, and here I have to say fill again. And then the X and the Y, so there's no this keyword here, it's self dot and then loc.x, self.loc.y, and then we need the size, so it's the width and the height. So I'm actually going to come up here and say t.size equals, let's see if 10 is visible. And I'm going to just say self.size, self.size. Okay, that should give us a bird. Let's run this and see what happens. That was not the right command. 2 up arrows. Hey, top left, we have a little tiny red square. We got a bird. Okay, I mean, this is really cool, right? I mean, we want to do a lot more. So now we want to say, hey, we have gravity. When this bird just exists, it starts falling down and then eventually dies. Okay, we can do that. We're going to use vectors to do this. So once again, I like to code as if the code exists and then add into the class to make it exist. So we have vectors in here. Let's set up local gravity. And then in here, we're just going to say gravity equals vector.new. So here's what you have to think. Where does it want to pull? Because vectors are just x, y locations. But when you start adding or like doing multiple vectors together, you get interesting things. Where you can say, like, I want a direction between 2 points. Or I can say, where is the vector right now of the bird? That's 10, 10. And then I want to say, okay, well, I want it to move towards another point. Well, I want it to probably move towards like 10, like 50, or 10, 1,000, like something down from it. But I don't need to know where the vector of the bird is. I can set a relative vector. So I can say 0. I don't want it to change the vector at all here. And maybe 5 or 10. We don't know. We're just going to make up this number. All we know is that it's a positive number because as we go down on the page, y goes up. Then, not in draw, but there's another special function called update. And update is something special because it's going to be run the same, like just every time the draw runs, update also runs right before draw, and update will pass you a really tiny number called delta time. And that's the amount of time in seconds since the last time that the screen refreshed. We're going to use that to try to make the animations really smooth, because if you like pause the window or like your computer starts like not doing so hot, then weird things start happening. Okay, so the first thing I want to do is I want to cap the delta time to 60 frames per second or so. So I'm going to say if delta time is greater than 0.029, which I just memorized as 60 frames per second, then delta time equals 0.029, end. If statements are also a little bit odd. There's no parentheses either here. We're just saying like, hey, if this, then that, and then there's the end statement. I actually like this about Lua a lot. It makes it very readable. Okay, so what we really want to do here is we want to tell the bird to be affected by the gravity. So I'm going to say bird, apply force, and then hand it gravity. Okay, that's cool, but we now need to write all this code in here to work. The only changes we need for bird is to write in, well, we need a little bit more. We need to actually bring in vector now. So local vector equals what? Stop doing that. Vector. Then inside of here, we need to do a little bit of tricks that I learned in some of the art stuff that I was making. We need to set special vectors up for the movement. So we already have a location, but we need to set an acceleration equals vector.new, and then we're going to initialize it to 0, so it's not moving at all. And then t.velocity equals vector.new, and it's also not moving. Now in apply force, function bird apply force. This takes in a force vector. And here we're going to say, okay, add this to acceleration. So, self.acceleration equals. There is no plus equals in Lua. You have to do everything explicitly. So, and there's also no plus plus because Lua doesn't like that. So, self.acceleration plus force. This is where we're getting a little bit of benefit from the vector library. It's done a little bit of overloading here, so we can just say plus this, and the library takes over and does all the cool stuff it needs to do. Now there's one more thing I forgot to do right here. We need to actually make the location change. So in update, I'm also going to say bird update and pass it delta time. So we need to come here and say function bird update delta time. And then we're going to say, okay, self dot velocity equals self dot velocity plus self dot acceleration. So here's we're going to take like, hey, acceleration, add to velocity, whatever you are. But then we need to say self dot location equals self dot location plus self dot velocity. Okay, we're almost done. Finally, to make sure that every time we increment and add on to the force onto the acceleration, it doesn't become, really, really fast, we reset acceleration down. So we say self.acceleration equals self.acceleration, and we'll just multiply it by 0 to reset it. What this is doing is just saying like, hey, x times 0, y times 0, but it's not actually setting acceleration to 0. Okay, that's a lot of code. Let's see if this works. Okay, I don't know if you caught that. That was really fast. That's because it's running at like who knows how many frames per second. But this delta time will help us out here. What I'm going to do is I'm going to say multiply this entire thing by delta time. It's going to slow it down and tie it to the number of frames per second. So let's do this again. Hey, that's a lot smoother. Okay. That's cool. We got a bird that falls and dies. I mean, it sounds pretty bad. We just can't save the bird. So let's change that next. The next thing we want to do is we want to say, hey, whenever you press the space bar, I want the bird to like flat upwards and not fall down infinitely to its death. So Love actually has some really cool documentation in this wiki. So if we come to this, and I'll make this slightly bigger so you guys can see it. On the left here, I'm going to come to keyboard. And at the bottom here, we can say, hey, love.key pressed. When this happens, it's going, like every time I press the key down, it's going to come back to me with the key that was pressed. What's more thing that's cool is scan code. If you guys, have any of you guys ever changed your keyboard layout to something that's not just like default QWERTY? Am I the only one that does that? You, okay. Doesn't it suck playing games when like they mess around? Yeah. Well, this allows you to scan code, which is the actual key, not the remapped key. So it allows you to say like, regardless of whether or not your W key is an actual W key, if they press it, do something appropriate to it. That being said, I've never known anybody to map spacebar away from spacebar, so we're just going to use key here. So, at the bottom of main, what I want to do is I want to say function love.key pressed, and it's going to be key. And in here, we just want to say, okay, if the key is equal to a space. And I forgot then, that's why the spacing got messed up here. So if the key is a space, what do I want to do? I want to tell the bird to flat. Well, if I come over, now I have to write this function. So function bird flat. So what does this really mean? I want to stop all downward movement. So I want to first say self.velocity equals self.velocity times 0. I want to set that to absolute 0. But then I want to now create a new force. So I'm just going to say local force equals velocity dot new vector dot. And what do I want to say? 0 is not going to flap forward, it's going to flap straight up. So 0 on the x and maybe negative 10. Let's try it, see what happens. But before I do that, I have to say self.apply force and hand it the force. And that should be it. That should let us fly. Let's find out if I'm actually correct here. Well, I can slowly stop its descent. I mean, it did stop it, but it didn't really go up. So let's try making that a little bit stronger. Like, play changes to like negative 200. Yes?
You put self-colon apply force?
I did put self-colon apply force. Lua is fun in that way. In order to maintain the ability to get the self, which is the equivalent of this in most other object-oriented languages, you have to use the colon to pass the entire state, essentially. So let's try 200. Hey, look at that. It bounces up. Okay, well, I mean, this is cool, but of course, Flappy Bird isn't about just trying to keep a ball in the air and not hit below. So we need pipes. But this is like the basic ones, and I hope that you're starting to see how Lua comes about with this. So with that being said, let's pretend we have some pipes. So local pipe equals water pipe. I am totally not going to do the best practice here. I'm going to say local pipe 1 and local pipe 2. So in here we just say pipe 1 equals pipe dot u, and we're going to need a P1 location. So I need to create that. So let's do local P1 location equals vector.new. The first pipe needs to be in the middle of the string. So that's going to be width divided by 2, but it needs to start at the top. So 0. And we can just copy this and do P2 location equals vector.new. Well, this one's going to start at the end, after the screen is. So starting at the end of the screen, which is width itself, and 0. Okay, so pipe 1 equals pipe 1. Let's create this pipe 2 location. Okay, then we want to display both of these. So this is pipe 1 display. Pipe 2 display. Okay, let's just do this and see what happens. Let's go over here, do a new file, pipe.lua, and move this over to the right. Okay, I'm actually going to cheat a little bit and copy my bird over to pipe. So that way I don't have to copy everything, and then I'm going to use my editor's magic to rename everything that's a bird to a pipe. This is another reason why I use local t equals empty object, because uppercase pipe and lowercase pipe would kind of select the same, and add them, that just makes me upset. So, pretty much everything is going to remain the same here. We're not going to change too much. The location comes in here. The size is now going to be a width. So let's change this to a width, and let's make ours 25. Acceleration of velocity, I'm perfectly fine with keeping those. Display, let's not have the same color of pipe as the actual bird. What color pipe should we have?
Green.
Green. And here we're just going to say self-location x, self-size, and then self-size, well, it's not going to be a square, so we need to change that. So self-size for the width is fine, for the height, let's change this to just plain old height. And then apply force, like all of these other things, they're not really going to do anything until we start calling them. We don't need flat, because pipes, last time I checked, don't flat. All right, we got an error. Okay, bad argument number 4 to rectangle. Number expected got nil. All right, so what problem did I have here? I had number 4, so 1, 2, doesn't have the next. Height?
Change self-size and access that.
Oh, self-size width, you're right. So, just like JavaScript, that was not like a full array. It was trying to be nice to me and auto set that to like, nil instead of just completely undefined thing. Yes?
Is the screen that comes up when you run the app, is that like similar? Like, is that a browser? Is that like a on the browser? Like, what is this screen?
Oh, this is a native Mac OS window. So, Love, when it creates a native window, and you can actually export this to Windows or Linux. And technically, iOS and Android too. Although I haven't done any of those. Okay, so we've got a pipe. This is a really impossible game to play because there is no hole in this pipe. Let's see what we can do about that. This is just going to be a lot of kind of math type things. We're going to say t dot like gap equals, how big is our gap going to be? I'm thinking 100 pixels. It's just a guess. And then t dot gap location equals. So I want this to be random because it's not really that fun of a game if it's always the same location. Love actually has a random function in it, and we're going to set like where we want it to be. So I want this to be like y. So let's say it has to be a minimum of 50 from the top. The y is going to be a little bit more interesting. We want to say from the bottom, it needs to be at least height, but then minus, and then 50 minus t dot gap to give it that like full amount. Now, with that being done, we can change this rectangle here. So we have a rectangle fill. It goes from width to height. Well, it doesn't need to be the full height. It is now going to be self dot gap location. And then we're going to repeat this again and say, okay, well, now the starting location, x is fine, but the y now, self.locate.y, this needs to change to gap location plus self.gap. The width is fine, and then the height. Well, I can actually make this whatever height I want, right? I could just say height, and nobody cares if it extends way down below the bottom because you're not. I could do the math to like figure out exactly where it's going to be. It's like, who really cares? So that gives us a pipe that has a hole. And if I refresh this, well, that was almost the same place. It's going like slightly down by like 10 pixels each time. There, that's taller. Okay. My 50 down is probably actually too much. I can change that here. I can say, you know what, let's go 10. And let's change this to 10. Ah.
Gap size random.
I could make the gap size random too. It still wants to be in the middle. I love random generators right in talks, right? Okay, well, let's now make the pipes move to the left, because that's like another important part of playing, because I can play forever, but if I don't pass any pipes, I can't score. Well, what I can do is I can just apply the force to the pipe. So I can either do that here. I can say t dot speed equals negative, well actually it's going to be vector, isn't it? We brought in vector, so it's vector dot new. This is going to be the x movement. So let's say -5 and 0. And then I want some kind of method here. It's going to be similar to flat. It's just going to be a function height move. And I want to say self dot or self apply force self dot speed. And that's really all I need to do. Over here in the main, I now need to tell these pipes in update to start moving. So let's figure out how to do that. We're going to want to say pipe 1 colon move and repeat that with pipe 2. Let's see if this works. Didn't really do anything here. Okay, so what am I doing wrong? I've got my move, I'm telling it to move, I'm not telling pipe to update though. So I need to do that as well. I need to say pipe 1 update and repeat that. Because otherwise it never actually updates the location. And then again, wrong argument types. Vector or number expected in vector Lua 78, but what's really cool is in these error messages, it actually tells me the last time it was in my code, which was pipe Lua 31.
Did you DT?
So if I come over here, pipe Lua 31, self.velocity equals self.velocity plus self.acceleration times dt. I did not hand it dt in here. Well, so there is a problem here. If I just literally say apply force just the same way I did the other one, it will actually continually increase speed. There's a much simpler way for me to do this, which is not use this at all. But when I set the pipe up, come into the velocity and just auto set it as like -3. And now I don't need to do pipe move. Now the pipes automatically move. So technically I have a playable game now. I mean, the pipes don't reappear, and I only have like this one level that I play. But the game is like, I can play it. I can try to get through the pipe. I can't die because they don't have collision detection. And I have 8 minutes left. So what I'm going to do is I'm going to make it so that the pipes come in forever. And then we're going to see how we are and maybe take questions. Okay, so if I want to take pipes like forever and do that entire thing, I need to check in update here if the pipe is to the left of the string. So I'm going to say if, I can actually call a function here. So I can say if pipe off string and then pass in pipe 1. If that is true, then I just want to reset pipe 1 with a brand new pipe. I'll start over. So I'll just say pipe 1 equals, it's going to be pipe dot new. And then it's going to be a new vector. So I'm just going to say vector dot new. And it's going to be, the x is going to be the width, and then 0. So it's a bit of a big one-liner, but I can do this twice. Now I do have to write this function here. Type 2. That's it for there. Let's go write this function. So function pipe off screen. This takes a pipe. Okay, so in here, what do we want to check? We want to check to see if the x plus the width of it, if that's to the left of 0, well, then we know there is. So we can just like most languages, I can just return and then do the actual math right here and it'll return a boolean. So pipe dot, well, location dot x plus pipe dot width is less than, I'll just do less than instead of equal to. Okay, if that's less than 0, then it should be to the left, and that should just create new pipes forever. And now we have infinite levels that we will never possibly win. We can only lose eventually. But that's kind of like the real Flappy Bird game. And technically this is playable if you just pretend that you die and close the game yourself as soon as you hit the collision detection. So that actually only took 3 minutes to do. Okay, really cool. Collision detection is a little bit interesting because I have to collide the bird with both pipes. I don't know which one is the next pipe because I'm replacing them. I'm not doing any kind of state machine to figure out where the pipes are. So I need to track that. I need to figure out, like, hey, if you're colliding with the upper pipe or the lower pipe, but they're one class, okay, it gets complicated. So what I want to do is I'm going to actually come over to my notes here because I actually wrote these functions down because I knew trying to live code this math would be really tough. This is the only part that I'm not live coding. Sorry. Okay. 3 functions here. Pipe, and this actually needs to be in the pipe, not the bird. That would have been kind of a funny, like, oh, you prepared and then still did it wrong. Okay, pipe, check collision bird. Well, that means that inside of my update, I need to call this check collision and pass it the bird in for each of the pipes. And what this is going to do is it's going to return a Boolean, true or false. So what I can do is over here in update, do this right here at the end, you can say if pipe 1, colon, check collision, pass it to bird. So if that is true, just like most other languages, I don't need to actually say, like, are you true or not? It'll just, truthy is a thing there. If that is true, then I want to say bird dot dead equals true. Now, I could just set that. I do want to go back into the bird and like explicitly say that there is a dead thing there, but Lua just lets you do that. Randomly, you don't have to explicitly state things in the class. And then we can do the same thing with type 2. Okay, that's cool. So let's go back to bird. And let's set dead thing there. T.dead equals false. It totally starts not dead. Okay, and last thing here is we want to say in the draw, don't draw the bird if it's dead. So if, and here's one of the coolest things about if statements. I can say if not bird.dead. There's no bang here. It's just all words. Then display the bird. Okay, let's first see if this works, and then I want to come back here and explain this fun collision detection I have, because I think that deserves a couple seconds over. So it works. Let's see. I can pass through the pipe, and if I come up here and die, bird disappears. Okay, cool. Game works. There's no scoring system, but I always figured that getting the scoring system in here as well would be a little bit tiny a stretch here. Let's go over and talk about this collision detection, because this is nasty. Now, how many of you have made games? A few. How many of you implemented your own collision detection? Awesome. How fun was it? One person. Okay. So when I was writing this, I did this on stream, and it took me way longer than I thought it would. Now, I've done normal bounding box, like rectangular box collisions before. This one was a little bit different because I have to take into account that gap in the middle. And I have to make sure that it returns false for colliding if it's in the gap. So because of that, I ended up deciding to break the entire collision detection into 2 different functions. Collide X and collide Y. And that allowed my brain to sort of think about it in a separated way and also hopefully explain it a separate way. But look at this fun right there. Let's actually make this one entire. Come on, you can do it. Here we go. Okay, so we're checking to see like, okay, is the X location, is that like, is the top left corner or the top left side, is that quite in there? We have to have this fun OR statement here. That's what makes this so difficult, is the OR statement. Because then we take both of these and we combine these with an AND statement there. That's the reason why trying to do this all in one line is like the worst idea ever, or at least in my mind. I totally could understand if somebody puts this into a library and just hides it in a file called do not touch black magic happening here, which is most collision detection anyways. It's the reason why a lot of people might be scared away from something like Lua and Love2d, because it doesn't provide collision detection for you. But I maintain, just like Jack Rugow's talk last year with every developer should make a game, that going through this is going to improve your day-to-day programming life because it makes you really think about the logic of stuff and actually like work through really tough problems. And also try not to slow and crash the game at the same time. So, with that being said, I have run out of time for the official talk because it's supposed to be about 45 minutes. I have everything except a score system in place. This entire game is, at this point, fully playable. So, with that, any questions?
Could the score system just be at a point every time you new up a new pipe?
Yes, the score system is actually pretty simple to add in. That being said, it's a little bit difficult to say like when it passes by a pipe because these pipes are 25 pixels wide and you'll hit a function if you're like, oh, if you're in between a pipe, it'll hit that function multiple times. And then also the pipe exists to the left of the bird for a while. So my method of fixing that problem is say whenever the pipe disappears and gets refixed and like put over onto the right, that's when you implement the score. But as long as the player doesn't somehow die in between that, they'll get the point. Any other questions? Yes?
Is there a z-index to the elements on the screen?
Oh, great question. So, no, there is not. Love2d is a two-dimensional framework. There are people trying to make Love2d into a 3D framework. It's in super like alpha mode right now, and I wouldn't suggest it. Personally, when I make more 3D like tech games, I'll either jump into Unity or processing or P5.js because that does give you like 3D right out of the box. Have I inspired any of you to try to go make a game? With Love and Love2d? No? One? Okay. Well, I guess for one or two people, my job is done. Well, with that being said, that is my talk. Thank you guys for stopping by.